In this video, I'll be going over my Nerf Rival Challenger battery mod. I picked one of these up along with some nickel metal hydride batteries, as I'm not keen on using disposable alkalines. I've seen some rigging lithium batteries to blasters, and that seems problematic in other ways, such as safety, complexity, cost, and a need for physical modification. I wanted this mod to be non-destructive. Since 8AA nickel metal hydride batteries at 1.2 volts outputs only 9.6 volts, and 8AA alkalines at 1.5 volts makes for 12 volts. My thought was to rig in two more 1.2 volt AA's to get to 12 volts. My idea was to make a replacement battery cover with a bump out for a 3AA battery compartment, with those 3 AA's rigged to a dummy cell that would sit in place of a remove cell. I started with designing a AA dummy cell. I figured I'd use brass wood screws for the terminals that would screw into wiring leading to the battery compartment. That worked out pretty decently. The screw terminals allow one to nicely fine-tune the length of the dummy cell to match that of a AA. I used a larger brass screw for the negative side and a smaller brass screw for the positive side of the dummy cell. This is the exact battery compartment I went with. The exact dimensions were provided, allowing me to design the bump-out compartment before I had the battery holder in hand. Next came designing the battery door itself. I did a highly parameterized design in OpenSCAD so I could fine-tune it afterwards, which came in handy, as multiple parameters indeed needed fine-tuning to get a good fit. It took 9 versions to get a decent fit. I printed it with 300 micron layer thickness, in the best quality my printer is capable of. It's around 45 grams of filament, including support filament, and took around 2 hours to print. It was actually slightly beyond the build volume of my printer, though fortunately only by a few millimeters. I needed to trim a millimeter from the top and bottom and print without a raft, but was then able to get a functional print. Here's a time lapse of it printing. The version shown here doesn't fit the best. Again, I needed to make some additional tweaks. The next issue were the screws. It seemed like some go the route of thumb screws for the battery compartment, which is a good idea. Though instead of buying overpriced metal thumb screws online, I figured I'd try making my own with common M3 screws and hex nuts, which I did have on hand. I designed a 2-piece thumb screw set. The M3 screw gets put through one piece and a hex nut secures it to that piece. Then another piece fits over the hex nut and holds that nut in place, with a gear-like pattern securing to the other piece. That same gear-like pattern also is used for traction on the outer portion of the piece. It seems to work pretty decently, plus it matches the color of the door. And here's the finished result. The battery holder fits in the bump out and is connected to the dummy battery. This allows 10 AA's instead of 8, for use only with 1.2 volt AA rechargeable batteries. Now for some pitfalls and additional considerations with this mod. The battery holder I'm using in this mod appears to be using 28 gauge wires, which are quite thin for this use. Replacing those with thicker gauge wires would be a good idea. The terminal wiring also appears to be on the thin side, at 0.72 millimeters for the spring terminals, and 0.6 millimeters for the solid wire connecting opposite corner terminals. That seems like the equivalent of 20 to 22 gauge wiring respectively, which is still on the thin side. Finding a battery holder with thicker gauge wiring and terminals would have been best, though it seems like most 3AA battery holders use thinner wiring, as they aren't intended to be part of a higher voltage need. The spring terminals do seem comparable with those of the stock blaster. Rigging up some additional copper wire in the battery holder could help, as could bridging connected terminals with additional copper wiring. Checking for voltage drop while revving the flywheel motor seems like a good simple way to check for wire bottlenecking. Also, if your nickel metal hydride batteries run a bit more over-spec voltage than usual after charging, you might want to consider 9 instead of 10 AA's. Which you can do by substituting in another dummy cell. Lightly used Eneloops I have seem to charge to 1.45 volts, whereas the old Duracells I have seem to charge to 1.4 volts, and the brand new Energizers I have seem to charge to 1.37 volts on the old Duracell charger I have. Will overvoltage to the flywheel motors of the blaster damage it or shorten its service life? Maybe. So suddenly all this talk of a non-destructive mod might be in some doubt. depending on what you run it at, and additional improvements in wiring. Perform this mod at your own risk. I'm not responsible for damage, lowered service life, fires, or ripping a hole in the time-space continuum. Plus, this will void your warranty. Don't use it around combustible materials. Keep a Class C fire extinguisher on hand at all times. Keep it out of the reach of children. Always use protection. And for the enjoyment of others, no smoking, please. Now for some feet per second results. With 8 charged nickel metal hydride batteries measuring 10.78 volts without revving, and 10.08 volts while revving the motors, stock wiring yielding a 6.5% voltage drop while revving, I was getting around 73.8 feet per second. With 10 charged nickel metal hydride batteries measuring 13.57 volts without revving, and 10.64 volts while revving the motors, thinner wires, yielding a 21.6% voltage drop while revving, I was getting about 78.7 feet per second. With 10 charged nickel metal hydride batteries measuring 13.31 volts without revving, and 11.33 volts while revving the motors, 18 gauge wires from the battery holder, additional copper wiring installed in the battery holder yielding a 14.9% voltage drop while revving, I was getting around 83.7 feet per second. Check out the description for a link to the models and other parts used for this build.